Identify constant variables across containers. The problem states that 4 identical rigid containers, which means they have the same volume, V, are maintained at a constant temperature of 273 Kelvin. Apply the ideal gas law relationship. The ideal gas law is expressed as PV equals nRT. When volume, V, and temperature, T, are held constant, pressure, P, is directly proportional to the number of moles of gas. Np is proportional to N. This means that containers with equal pressures must contain the same number of moles of gas. Use container 4 as a stoichiometric reference. Container 4 contains sulfur dioxide, SO2, at a pressure of 1.96 atmospheres with a sample mass of 64.1 grams. The molar mass of SO2 is calculated as mSO2 approximately 32.1 grams per mole, S, plus 2 times 16.0 grams per mole, O, equals 64.1 grams per mole Sol for the moles of gas in container 4. N equals mass over molar mass equals 64.1 grams over 64.1 grams per mole equals 1.0 moles. Relate container 3 to the reference. The pressure in container 3 is 2.00 atmospheres, which is extremely close to the pressure of container 4, 1.96 atmospheres. Since the pressures are virtually identical, the two containers must hold approximately the same number of moles of gas. In container 3, approximately 1.0 moles determine the molar mass of the unknown gas in container 3. The problem lists the mass of the sample in container 3 as 16.0 grams. Using the number of moles estimated in step 4, molar mass equals mass over moles approximately 16.0 grams over 1.0 moles equals 16.0 grams per mole. Identify the gas matching this molar mass. Compare the calculated molar mass of 16.0 grams per mole to the options. Methane, CH4, has a molar mass of 12.0 grams per mole, C, plus 4 times 1.0 grams per mole, H, equals 16.0 grams per mole. This confirms that the gas in container 3 could be CH4, making option A the correct answer. The correct answer is option A, CH4.